In this video, I have another example for you of a hypothesis test for two proportions from independent samples. And we're going to be using the problem you see on the screen in front of you right here, number 32, which is titled Confidence in Public Schools. Now, before we get into it, I want to suggest something that I think is important. In my experience, I notice that many people struggle to recognize what a problem requires in terms of an approach or a process or a built-in function when they encounter the problem stripped of context. In other words, it's not uncommon to find that people are sort of unconsciously maybe using the section of the textbook as a crutch to help them figure out what I should be doing to approach this particular problem. So let's read this one and think about that. It says, in June of 2014, the Gallup organization surveyed 1,134 American adults and found that 298 had confidence in public schools. In June of 2013, the Gallup organization had surveyed 1,134 American adults and found that 360 had confidence in public schools. Now, we wouldn't expect the two samples to generate exactly the same proportion, but anyway, the headline that they're asking us to respond to, it says, suppose that a newspaper article has a headline that reads, "Confidence in public schools deteriorates." Is this an accurate headline? Why? So, the first thing that you might consider is, how do we know that this is a hypothesis test for two independent proportions, or proportions from two independent samples? I think that's a good question. And if you think about it a little bit more, you might want to ask yourself, well, what would we be using as our alternative hypothesis here? Obviously, that's always the most important of the two. And so let's jot down a few things here, and we'll see how we're going to respond to this. I'm going to show you how to do this with a confidence interval as well, because we do want you to be able to reconcile the hypothesis test and the confidence interval approach. And so we're going to show you both in this particular video here. Let's see what we've got. So since the order of the samples is arbitrary, I decided to go with 2013 first because of the chronological reason. And so as you can see, the sample size was the same for both years, and the number of individuals who had confidence in the public schools differed. Now, we're being asked to assess whether or not the headline is accurate. And again, if you look at the headline, it's asking, or it's stating rather, that confidence has deteriorated. And so we have to think, well, what does that mean in terms of an alternative hypothesis? Now, I have the null hypothesis there, and that's an easy one to get because it never changes. It's always a claim of equality. And then down at the bottom, we can consider what we have written there in order to figure out which is the best choice for the alternative hypothesis. Now remember, the calculator forces you to put p sub 1 on the left of the alternative hypothesis. So for that reason, I'm not considering the other direction of subtraction. I'm just looking at this particular direction here. And if the confidence has deteriorated, then the proportion of individuals in 2014 should be less than the proportion of individuals in 2013. And hence my first candidate there for an alternative hypothesis, p sub 1 greater than p sub 2. Or if you will, p sub 1 minus p sub 2 greater than 0. I think you could also make a case for testing this as a two-tailed test, but I don't know that the answer would be as clear. So in other words, think about it. If you reject the null hypothesis with a two-tailed test, really all you're saying is that they are different, that the proportions differ significantly. But we're not being asked to assess whether the proportion differs significantly. We're being asked to assess whether or not it has deteriorated. And so I would say for that reason that the first choice there, the directional test, the right-tailed test, is probably a more defensible choice for your alternative hypothesis. But I think you can make a case for both. And so I'm going to go with that. Now, we probably want to make sure that even though it's not explicitly asked, that this is not a garbage in, garbage out situation. So we probably want to check those conditions that we had talked about in the previous video. We want to make sure that we're normal enough here. And so let's do that. the condition that we truly have to check is whether or not the central limit theorem applies. And so if you recall, the way I normally would check that is I would store the sample proportions in memory registers, and then I would run the following calculation. So from sample 1, I have 360 out of 1134, and I'm going to store that in alpha A. And then from the second sample, I had 298, and I'm going to store that in a different memory register. I'll use letter B. So I have those in there now, and now I can check normality. So I have sample size 1134 times my sample proportion times 1 minus my sample proportion. And we'll check the second as well. I just have to go in there and change that to B. The sample sizes are the same, right? So might as well take advantage of that. So as you can see, in both cases, the calculation gives us a value that's larger than 10. And so that would be something we would definitely want to record to show that we checked. And as far as the other condition, whether we have oversampled or not, in other words, we're supposed to make sure that our sample size is less than 5% of the population, I think we can safely assume that that is satisfied here. So we're going to jot this down, and then we're going to proceed with the rest of the problem. So I've recorded that I've checked the conditions there. Both those values are greater than or equal to 10, and so we're good to go there. If we're going to run this as a hypothesis test, this is going to be a 2-proportion z-test, and that would definitely be something we'd want you to write down. And so let's get those values. You're going to go to the stat menu, and you're going to use the test submenu, and the function you're looking for here is number 6, the 2-proportion z-test. So you can just type 6 there, and then put in your inputs. And as far as the direction of the test, if we're running it as a right-tailed test, we would want that p sub 1 greater than p sub 2, and we can then calculate. And so I would want to record that information right there, at least some of it. So I've jotted down my test statistic and my p-value. Those are definitely things we would want if you were recording this, say, for an exam question. And how about our conclusion? Well, in this case, the p-value is very small. Was there a level of significance given in the problem? Let's see. Looking carefully at the problem here, there is no level of significance. And a lot of times people will stop at that. They don't know how to react. But if you recall, the whole purpose of testing using a p-value is that it allows the reader to draw a conclusion without some pre-selected level of significance. And so it's not a problem that we don't have one. In fact, that's the normal way of things. And so as far as the p-value we got, which was very, very small, I would say we're going to be rejecting the null here. And so my conclusion is that since the p-value is so small, we reject the null hypothesis, and on a practical level, I would say that the evidence we have supports the headline. Now, if you were inclined, you could also test this using a confidence interval. Of course, without a pre-selected level of significance, it sort of begs the question, well, what level of confidence should I be using? Remember that there's a relationship between the level of significance and the confidence level. And so I think you could defend using a 95% interval. That is kind of a standard operating procedure, if you don't have a pre-selected level of significance, you could also justify using a 99% or even a larger percentage if you wanted. But anyway, the fact that you don't have a pre-selected level of significance shouldn't stop you. I mean, you can still make your assumptions plain and then show the test. And so we can check using 2 intervals and show you that the result is consistent. Take a look. Now you know that the 99% interval is going to be wider than the 95% interval, and I don't want you to take away the wrong conclusion from this example here. We're just showing you that you have some flexibility in how you approach it. Let's go back to our stat menu. We go to our test submenu, and we are looking for a 2 proportion Z interval. It's letter B on this menu here. And you can see that you already have your proportions in place. So really all you'd have to do is calculate. So for the 95% interval, I'll just leave it like that. There's my confidence interval. And notice that the endpoints of this interval are both positive. And so because they are both positive, that means that the interval does not contain 0. And the fact that 0 is outside of the interval suggests that we are 95% confident that it is not plausible. And so, in other words, we are 95% confident that the null hypothesis is not plausible, because if you recall, the null hypothesis was effectively claimed that the difference between the proportions was equal to 0. Here's my null hypothesis right here. And so again, even though we stated as p sub 1 equals p sub 2, we could also state it as p sub 1 minus p sub 2 is equal to 0. And so the fact that 0 is not captured by the interval suggests that we are 95% confident that this value, p sub 1 equals p sub 2, is not plausible. Let's run this with a 99% interval, and we'll show you that the result is the same still. If you remember that B is the letter that designates it in my calculator, I can just use that and go directly to it. The only thing I need to change is the confidence level. And so now I'm ready to calculate. And so once again, notice that both endpoints on the interval are positive, meaning that it doesn't contain 0, meaning that we are 99% confident that the null hypothesis is not plausible. Let's jot that down. Now again, I'm not suggesting that in order to test this using a confidence interval where they don't supply a pre-selected level of significance, that you have to run both intervals. I chose to do that here just to demonstrate that the results are consistent. But in any case, I think either one of those would be sufficient, and the conclusion would be that because the interval does not contain 0, we are 95% confident or 99% confident, depending on which one you used, or whichever level of confidence you used, that the null hypothesis is not plausible. Hope that helps, and if you have any questions, please feel free to drop me a line.